This good? You can hear it? Sounds good. Okay, great. So I was saying earlier, sometimes I wander around. I'll try to do my best to minimize wandering so that I can still be heard, but let me know, just someone yell at me if I'm too quiet or if I'm going too fast or if I've wandered away from the microphone accidentally. Apologies in advance. Okay, so hi, we're gonna just jump right in because I've got a lot of stuff to cover today. I've got this wonderful presentation on HTML, and now I'm gonna do a really cool thing that nobody will ever expect. Oh, wow. Wow, you didn't see that coming, did you? It's not just HTML. Oh, damn. Okay, so now let's talk about something really amazing that nobody has ever heard of before in their lives. We've got the basics of web development, the building blocks, wonderful HTML. We've got CSS, and we've got JavaScript. I know this is amazing stuff. We'll talk about it a little later. I know you guys might not understand it, but we'll get there, okay? So we'd all know these basics in seriousness, and in reality, not a lot of full-time web devs are just only using HTML, CSS, and JavaScript. When it comes down to it, we have a bunch of different tools that we kind of use, and these three base technologies sort of end up as compile targets a lot of the time. We end up using a lot of other things, and when the browser ultimately is putting the code onto a web page, it's going to end up as these three. But these are not the tools that we actually use. So I'm going to go a little bit back in history and talk about kind of moving up the ladder. So I'm going to highlight three specific languages that evolved, and these are not all three the most popular at the moment, but these were kind of the first steps as far as big popular compiled languages that ended up coming down to HTML, CSS, and JavaScript. So on the left, you might not recognize this one, but it's a wonderful and adorable logo. This is Pug, formerly known as Jade. It's very similar to Haml. If you've heard of any of those three, you know what I'm talking about. If not, I'm sorry. I've failed you today. It's a language that compiles down to HTML. And so it includes things like includes, loops, local variables, layouts, a lot of things that are really essential to building a website without much pain. Next to it, I'm sure you've all heard of this, it's Sass, a language that compiles down to CSS. Same sort of thing, variables, loops, mix-ins, things that just make life easier and more convenient. And on the right, a slightly more controversial option, but really the first mainstream compiled to JS target is CoffeeScript. CoffeeScript was at its highest point before ES6 existed, and I'm sure some of you may recall that ES4 and 5 are really quite bad and need a lot of help in order to be like a reasonably usable language. And so CoffeeScript kind of ironed out a lot of those quirks and was a great tool that was widely used across many, many developers. So now we will continue moving up to the next phase where I'll bring in a couple more tools. And so the difference with these tools here is that the first set of tools that I showed you were all what I like to call monolithic tools, in that they have a set of features and all of those features are shipped along with the tool in one package, and that's it. That's what you get. With these tools for PostCSS and Babel, what you get is the exact opposite of that. All of the features are outside of the tool. And this enables a lot of interesting stuff. So let's more clearly illustrate what I'm talking about. With a monolithic language structure, you have Sass here, and within Sass, you can use mix-ins, you can use variables, you can use a white space parser, which will let you drop the semicolons and the brackets, which are very annoying and I appreciate a lot. You can use loops, you can use nesting, etc. And all of these come within the language. You get them for free, you get all of them. If you're using it, that's great. If you're not using it, too bad. You get it anyway, right? With PostCSS, the core of the language is tiny, almost empty. There's nothing there. If you feed a file into PostCSS, it will come out exactly the same as you fed it in. When I started using Babel, I thought that Babel was broken and spent quite a long time being frustrated, being like, this doesn't do anything. I thought it was going to transform a JavaScript into something better, and it's just doing nothing, until I realized that you have to add the features from the outside. So you have mix-ins, you have My phone's not working. You have nesting, and you have a white space parser, and you have loops, and you have variables, and all of those are viable features, and if you want them, you take that feature and you add it to PostCSS, and it will work, right? So the question is, why would you do it like this? Why is this better? Why did I present that as the next phase of tools? And there are a couple of reasons. So the first one is a very easy, convincing win for any developer. It's faster. When you don't include a lot of features that you are not necessarily using, you're going to end up getting better performance. You can trim it down to just exactly what you need. In addition, the core structuring of the way the code is written for this tool is much simpler because it's a very basic and sharp tool. It doesn't do much. You add onto it just what you need. And when you have tools like this, they tend to have a more simple structure and end up running a lot faster than when you have very, very big bloated tools that do a lot of magic behind the scenes. I might remind you of something like Ruby on Rails, for example. Wonderful tool, it does a lot, but it's very, very slow in response. Another great thing is that, like I just mentioned, it is simpler, and this is a great thing for many reasons. First of all, it makes it faster, like I said before. I'm just going to keep looping around infinitely. Second of all, it makes it a lot easier to understand and contribute to the tool, which is my next point. And easier contribution might seem like a small thing, but really it's a huge deal, because when you take a really big, complicated project that hardly anybody can understand and contribute to, you'll often end up in a situation where if you would like to add some feature that would be useful for you, you're unable to do it. I mean, not a lot of people can go look at a giant code base like Sass and be like, oh yeah, I'm just going to go ahead and like make a pull request. You have to understand parsers, code generators, all the transforms. It takes ages, and Sass I think is a C-linked library, which makes it even more difficult. So when it's harder to contribute, it ends up stifling innovation. When it's easier to contribute, you have more people pushing in features, and you can end up moving forward with the kinds of features that people use faster. On top of that, with something like with a plugin platform like PostCSS or Babel, you don't actually need to pull request the feature in the first place. It doesn't need to be a feature that anybody else uses for you to have the feature and use it. You can just make the plugin and use it on your project immediately as soon as you're done making it. You don't need to deal with any review. It doesn't need to be part of a package pushed out to millions of people. So that also helps to enable faster innovation, because you can start, have your idea, make your thing, put it out on the internet, and maybe other people use it and maybe they won't. But there are so many people putting them out and using them that the pace that we've pushed forward with PostCSS is so much faster than how we've ever pushed forward with something like Sass. And it's the same way with Babel, that it really helps to move things forward, and it's fantastic. So you might recall this slide from a really long time ago. You might not. Let me take an awkward drink. And there is a gaping hole in this slide, which I'm sure many of you noticed because it was so subtle. And it's this giant question mark above HTML. Why do we not have a plugin platform tool? I'm sorry, I never explained this vocab, but I call these two tools plugin platforms because they don't do anything and you add plugins to them and now they do something. I just made up this term. It's not a real thing, but maybe it will be now, hopefully. So there's a kind of this gaping hole on the HTML end. There's not really any way to do this same type of transformation. And so shockingly, this is what the topic of this talk is. It's a tool that's called Reshape that I've been involved with building, and it's had some really great results. So welcome to this talk. It's called HTML Enhanced, now that I've given like 10 minutes of context. And we'll really get started now. It's really just a thinly veiled talk about this tool called Reshape. Okay, so the first question, to add even more context, is why was this HTML tool so far behind? We had Babel for a really long time. It's super popular. It's a household name. Almost every project uses it. We've had PostCSS for forever. It's a fantastic tool, extremely popular. Why is there this giant gaping hole in the HTML region, and why does nobody know what Reshape is at all? I'm sure not a single one of you have heard of this, right? The answer to that is a little bit convoluted, so let me go on a quick tangent and then I'll come right back and answer it, I promise, okay? So the general way that web development has worked over the recent years is that it's moved at an absolutely insanely fast pace. I mean, if you think about just like 5 years ago, what was the state of the type of code we were writing? It was drastically different than anything we would write today, drastically different. And since things move so fast, it's really hard for every individual developer to keep up with the pace of how things go. And so in this specific industry, we tend to rely a lot more on thought leaders, essentially, many of whom have a title of developer relations. And I'm sure that all of you know or follow a few of these people, and they're fantastic. These are people whose full job it is to keep up with how web standards are evolving, test out different tools, decide what's a good direction to go in, and then write about it, present about it, and recommend it to other people. However, most of these thought leaders are working at really big companies like Facebook and Google particularly, have churned out a lot of this really cool technology and have a lot of people advocating and talking about the technology, and it's amazing. However, Facebook and Google are companies that build gigantic web apps specifically. And so all of the technology they push out and speak about is technology that helps to build gigantic web apps, which is great if you're building a gigantic web app. However, if you're not building a gigantic web app, and let's be honest, most of the internet is not made out of giant web apps, there could be some holes in what the recommendations that these people make are. So that being said, hello, I'm Jeff. This is my face in case you couldn't see it in front of you. I work at a company called Carrot. We're owned by Vice Media. Nobody's heard of Carrot. Most people have heard of Vice. We're an agency, and so we do not build a gigantic web app. Not at all. We build a lot of small to medium-sized websites. We build some larger apps, but really we just work on contracts that come through. My position is effectively developer relations, which is very unusual for an agency, but puts me in a spot where I'm always thinking about what type of tooling we can use to be more efficient for these smaller and medium-sized sites. And so the HTML portion was one of them. HTML is not that useful for giant web apps. Are you going to statically render HTML for every single Twitter user and every single tweet? No, it doesn't make any sense. It's impossible. It would be hundreds of millions of pages. You need to use more dynamic solutions for that. And really, HTML just doesn't make much of an appearance when you're building a big web app. But for us, when we're running blogs, smaller content sites, marketing pages, it totally does make an appearance because it's ridiculous to try to build a marketing site with React, right? And so we've kind of taken steps to fill in this gap. There's more context. Now I've spent half my time talking about context. So now let's actually talk about this tool. The way that plugin platforms work we'll cover first, and then we'll go into an actual example of how to work with the source and write a plugin, where I will live code and obviously make a huge mistake, and then you can laugh at me. And then we'll finish up with some cool examples of some interesting applications that we've run into so far. So how plugin platforms work. Step one, you take the string source of the file, let's say an HTML file, big old string, and you have to parse that into a format that's understandable through JavaScript. This format's called an abstract syntax tree, which is commonly referred to as an AST, which is how I'm going to refer to it from here out. If you studied parsers, you know all of this already, and you're saying, move on quickly. Don't worry, I will. Once you have the abstract syntax tree, and we'll look at one in a second and see how they look, it's a JavaScript object that's nested. It's a tree. You'll apply each of the plugins. So you give the tree to each plugin. Plugin can look through the tree, make some changes if it wants, and then hand back a modified or maybe unmodified. That would be a weird plugin, but you could hand it back and it will go to the next plugin, okay? Last step is it takes the abstract syntax tree and it generates it back into a giant string, and then you write that string to the file. So the base structure of this is pretty straightforward. Does anyone have any quick questions about that, or does that make sense? Okay, good. Okay, so let's play a little game. It's called Guess the Source Given the AST. Right here, I have a reasonably accurate Reshape abstract syntax tree. Take a look at this, take a moment, and see if you can guess what the original HTML that generated this abstract syntax tree is. This is a pretty quick one. So everyone good? Anyone still working? Okay. All right, was it what you guessed? So it's not really too difficult. This is very straightforward. You've got a div, that's obviously this div right here. It's got a class attribute of some class. That's this attribute of some class. And inside you got 2 paragraphs that say hello world in the second paragraph. Pretty straightforward. But this is a much more easily understandable format when you're working with JavaScript and plugins than just a string full of this stuff. And so that's what the parser is doing. Let's do one more example. This is a Babel one. This one's a little bit tougher because JavaScript is a little bit harder of a language than HTML is to deal with. It's a lot more complicated, that's for sure. So I'll give you a moment, see if you can figure it out. And I'll check how close I am to being out of time. Oh, nice. Pretty good. Okay, let's see the answer. Everyone got their guess? Boom. All right, that was a tough one. Okay, so this one wasn't so bad. Up top, we've got variable declaration. Oh, I can use my mouse instead of wandering. Yeah, look at that. Okay, so we know this is a variable declaration. Here's the name foo, here's the value bar, and the type is a const. Those are the important pieces of information. It's a const foo equals bar. Great. Okay, so that's our AST exercise. And now that we've done that, it's time for the humiliating experience of making a huge mistake while live coding. So let's jump on over to a text editor and get started. Every presentation, you've got a live code. That's my personal rule. Okay, so I've set up a little bit of the basics here to get started, and I put in a test file, so let's start there. I'm going to try to make a Reshape plugin here, and this is my goal. I want this input here. I just have empty div inside. It's nested a paragraph with this attribute of yell. It says hi there, and what I want is for any text node that has an attribute of yell on it to remove that attribute and then uppercase it so that it looks like you're yelling. This is a really great plugin, very useful. A lot of companies use this on their website, so I thought I would try to give a relevant example. So here is how Reshape works. It's a very straightforward API, not that complicated. You pass it some options, and here we're giving it the yell plugin. You process your input, and then the output is generated as a function. This is for reasons that are beyond what I want to talk about today, but when you call the function, it gives you a string, and we can just compare that string to our desired output to check and see if it works. In our index file, I have made the basic structure for a plugin. The plugin is just a function. It accepts a tree as an argument, and it returns a tree. That's it. Like I said before, it's given the abstract syntax tree, it gives back a modified version. In this case, it gives back an unmodified version, doing absolutely nothing. In the middle, it's just going to log out the tree so we can see it. So let me just boost the size of this a little bit. And I'm going to run my tests. I'm using Ava for this. And here our tests fail horribly because it did absolutely nothing. However, we do have this logged out tree structure, and you can see this is a little bit different than, is this visible? Yeah, okay. This is a little bit different than what we saw in the example because I've removed the location information. This is really important for errors and debugging, and I didn't want to remove it from the actual code base, so it's still here. But you can see that this is the same type of thing. We've got a div tag up top, we've got a p tag inside, it's got a yell attribute with empty text because it's just a Boolean attribute, and then inside of that we've got a text node that says hi there. So let's get started writing this plugin. If you have worked with trees before, if you took any computer science classes, I only took one and I got an F in it, so this is actually pretty difficult for me. You know you're going to have to use recursion to get through this, so we're going to start a function here called walk to walk the tree, and it's going to take a tree and it's going to take a callback function. And what we're going to do is just take the tree and map it to the callback function, and that's the end. Just kidding, it's not quite the end. So here I'll call the function, I'll pass in a tree, I'll give it a function, and each one we want to get the nodes out. So our goal here is to have this function walk through and to give us every single node in the tree no matter what the depth is. So I'm going to log out the node, and we're going to run our tests again. Okay, is this going all right so far? Okay, all right. So here we have failed horrendously on a recursion because we didn't do any recursion, but we've got the basics in place where it spits out the first level of our tree. It just gives us the top level div. Now we need to dive into the contents and walk through all the contents no matter how deep they are, okay? So what we're gonna do is we're going to modify this, and we're gonna do a little bit of extra magic here. So you can see here that if the content is an array, then we know that inside we've got another tree. For text nodes, the content is just a string of text. So what I'm gonna do is check if the content is an array, and if it is, I'm gonna recurse. So I'll do array.isArray, node.content, and if it is, we will call walk with node.content, and we'll also pass through the callback. And I could just one-line that. It's an easy one. Okay, and then additionally, we still need to do those top-level nodes. Just this would be forgetting about that, so we'll pass the node itself into here. And based on the position of this or that, it would be a top-down or bottom-up recursion. I kind of prefer bottom-up. I don't really know why. Remember that I don't have any computer science background, so this is what I'm doing here. And now you can see we've got all of the nodes back, and it starts at the bottommost node, right? This is the most deeply nested one. It's just the text that says hi there. And then all the way at the top, we've got our top-level div tag. So this is going pretty well so far. We wrote a recursive function to walk an abstract syntax tree. Amazing. Okay, so what is the next step? We need to find any nodes that have a yell attribute, and we need to just work with those nodes. So let's do if node.attributes. Well, that was a fail. Because some of the nodes don't have attributes, so I don't want to crash that way. And node.attributes.el. Then I'm just going to log that node, and we're just going to make sure that we've filtered it accurately here. Okay, cool, we've got it. Now inside of this one, we have another little tree inside of here because any node could contain multiple nodes inside of it. So while we only have one text node here, we still will need to actually walk this again in order to get an accurate result. And we also need to remove that yell attribute because if we don't, then it will still say yell in our output. Our intent is to kind of have the yell on there, have it make it yelling, and then get rid of the yelling. So first we'll do, that's a good spelling. We'll delete the yell attribute here, and then we will just go ahead and say, we'll do another walk. So we know that we're going to walk the node contents, and inside of here, I'll just do n2 for node 2. And at this point, we should be getting back just our text node. So I'm going to log that out, and we'll see how we're doing so far. Oh, yeah, sorry, wrong one. This is what happens when you live code, I'm sorry. Okay, great. We've got the text node. It says hi there. We're in good shape. And if you notice in the output diff, we have effectively removed the yell attribute. It's not there anymore. The only thing we're missing is upcasing this. And at this point, it gets pretty easy. Whoops, that was not correct. Okay, so that should rewrite it to be uppercase. Wow, is there a... There's a capital here, yep. Okay, see, this is what happens. That's why you never live code, my friends. Okay, so now we have a passing test. Woo, we did it. Okay, so that was a live writing for Reshape plugin, so not too intimidating. However, there are a lot more interesting things that you can do with this than just making a plugin that uppercases things. So let's talk a little bit about some of those actually relevant uses. First one is we have a wonderful set of standard plugins, and I call these standard because we package them into this effectively preset. You might be familiar with Babel's presets. They have one for ES 2015. It contains a bunch of individual plugins that do transformations on one feature. In the same way, we have a preset of standard plugins that most people find useful, and it contains a couple of things. One of them is layouts. It uses a block and extend system, much like Jade if you've ever used it, or now Pug, I guess. We've got expressions, local variables, loops, conditionals, includes. There's English language parsing and also foreign language parsing. So you can run plugins that will check if you've put in offensive words or insensitive phrasing, and it will warn you about that. There's beautification and minification. It will make sure your screwed up indentation is not screwed up anymore. It'll minify things in production. We do have a white space parser. If you are a fan of Jade or Pug or Haml, I am personally, as you might be able to tell. I don't like closing tags, and I do like indenting my HTML correctly. We have one of those, so it'll work perfectly. You can put it in and remove it without having it be attached to any of the other features. It's just a parser. So that's pretty cool. Another one is I've got to mention React or else I won't be hip. So here I am mentioning React. You may have heard of React's server rendering, which is a really cool thing that helps with performance a lot on large web apps. But we've come up with kind of an alternative way to use that called static rendering. And it's very, very useful for things that are not large web apps because a lot of the time you don't want to send an empty HTML root to your page because it's super slow, it's not very accessible, it's not search engine friendly, it's not social share friendly. You want to have the content, but it might just be a small marketing site that you're using one interactive section, and you're using React for it. It's not uncommon. So what I want for that is I just want it to render to static, and I can rehydrate on the client side. So what we've set up is a system where you can register custom elements like this, and you can pair them up with a React element. Here's a very simple element, nothing too crazy. It just takes a prop called foo and then renders a div that says foo as whatever that prop is. Really wild stuff, I know. So here's a very basic configuration. All of this is kind of some requires. Here's the important part. You can see that we have this one plugin called Render Components, which up here is called Reshape React Components. And in this configuration, you pass the name of a custom element, and as the value, you actually pass the React component, which you required up here, which of course is just in the same directory. And then you can process it and you can get an output like this, where it takes the custom element and it transforms it into the static initial render of your React component. Once you're on the client side, you can rehydrate it and get the interactivity back, but it buys you a very, very fast render, buys you great accessibility, search engine optimizations, things like this, without having to deploy a server and deal with any of that stuff. You get out flat HTML, CSS, and JavaScript files, and you can just shoot it right off to a static server. It's been an amazing tool for us and for our company in helping to build sites for especially big companies that have shared components across many sites and want to have something like a living style guide, but really do not need to build all of their basic marketing sites with React. It's just overkill. Here's another cool one, Webpack integration. Trying to be hip, guys, all right? Am I hip yet? No, I really love Webpack, though. Probably too much. So Webpack is really great. It does a lot of really cool optimization. It will take your scripts and it will split them up into multiple ones so that they can load in parallel over HTTP2. It will rename your scripts with hashes on them so that you have good long-term caching. All these great features. The unfortunate part is once you do all of those things, your script name gets mangled. So if you go like this and you've already renamed your script, broken up into 5 scripts and hashed all of the names, you're kind of in a bind, right? And you have to come up with some post-processing system that goes through and finds the right place and replaces it. Well, it turns out Reshape is a great tool for that since its sole purpose is to go through HTML and find things and modify them. And so what you can do is you can make a Webpack plugin that injects a Reshape plugin into your HTML pipeline. The Reshape plugin then receives the Webpack plugin's compiler context and has full awareness of what Webpack is doing. That way it knows the mapping of how your script has been broken up and how it's been renamed, and it can go in and essentially find your script tags by the original bundle name, find the pairing to their multi-outputs, and rewrite the outputs for you so you don't have to touch it and you never mess that up. Very, very cool, very useful, saves a bunch of time, and it allows you to have turnkey super, super particular performance optimizations like doing all of the splitting and hashing and stuff that you can just turn it on and it's done. You don't have to think about it. Really nice for us as well. Last one is there's this proposal out to the HTML working group for a generic H element that is not H1 or H2 or anything. It's just H. and it figures out how important it is based on how deeply it's nested. It's a fairly reasonable proposal. And so what you can do with the Reshape plugin is actually tell how deeply it's nested. It's very easy to do this. We just did something pretty similar. And so the guy who made this proposal for the H element, he built out a Reshape plugin that takes that code and transforms into this code. It just transforms, figures out how deeply it's nested, and renames it for you, which is really nice. A very cool way to implement it. Okay, so that's all I had to say today. Reshape is open source. It's available on GitHub. Surprisingly, this is the URL. I know, it's a little bit shocking. I have to do a shameless plug while I'm up here because that seems to be what's done at these types of things. We have another organization called Static Dev. In case you couldn't tell by this presentation, I'm a huge advocate of static websites. I really like them for a lot of different uses. Not gigantic apps, though. But we have this organization that has a few people from our company, a few people from other companies, and we're very active in thinking about the best way to run architectures for any other type of site that isn't a gigantic web app, because there are a lot of smart people that are way smarter than me already working on that, and so you can follow their lead. So if you are interested in this type of build, I'd encourage you to check out Static Dev. Reshape is one of our tools, but we have a lot of other ones. And finally, this presentation itself is also open source. You can go to slides.com/myname, Jeff Escalante, /HTML enhanced, and you can find all of the code for this. I'll let you take the picture. You could also just come ask me afterwards and I'll give it to you. Thank you so much for listening. I really appreciate it, guys. You're the best.
It was amazing, Jeff. I can already think of a ton of different things I could do with Reshape, with some of our marketing sites, and just being able to modernize those a little bit. Now, if you have some time, I think we're going to take some questions. Back.
Sorry, could you yell that a little louder? Okay, so the question was, how do you deal with legacy code when you're transitioning to post-CSS? I assume you're talking about Sass, like migrating Sass to post-CSS. There is not, as far as I'm aware, a code mod for it. There is every feature that you have from Sass available in post-CSS. A lot of the features and polyfills from post-CSS are not exact ports of Sass, but rather they are polyfills for upcoming CSS spec suggestions. So for example, there are CSS variables, there's a spec for this, and so the variables that are most frequently used in post-CSS is a polyfill for the official spec for CSS variables. Is that a change from the Sass syntax? Yeah, definitely. It's a pretty big change. And a lot of people have a little bit of an adverse reaction to it at first, but it's a web standard. And so it's kind of like it's kind of hard to lose that argument when you're talking about it. It's not going to be like a turnkey magical solution. I would just recommend taking it slow. A lot of people run both Sass and post-CSS. It's pretty common to run Sass and then run it through post-CSS just for auto prefixer. If you're already doing that, all you have to do is start removing the Sass slowly file by file and replacing it and adding in post-CSS plugins as needed. And that should ease the migration. Is that an acceptable answer? Yeah, I'm sorry. I wish I had a better answer, but since we don't have a lot of legacy code because I work at an agency, it's not something I run into frequently. Any other ones? Oh, sorry. Okay. Yeah, so the question was, is this an alternative to virtual DOM? The answer, huh? Shadow DOM you're talking about? Slap DOM? I have never heard of slap DOM in my life. Okay, so the question is this an alternative to virtual DOM? The answer is no, it's not even remotely the same. It's not even in the same scope. It's a completely different type of project. It is generating static HTML. Virtual DOM is for, it's a very efficient way to process DOM changes. Virtual DOM is effectively like, previous to virtual DOM, if you had data and you wanted to get it to update in the DOM, you'd have to select the element, change the content of the element. With virtual DOM, you put in a copy of the DOM how you want it, and the virtual DOM will calculate what elements need to be selected and changed and do that for you in the background, which is amazing, but it's not even anything close to what the scope of this project is. They absolutely can, yeah. I mean, you saw the example right here. React is used, you can render that React component to static, and then once your JavaScript loads, you can pick it back up with React and render in the interactivity on top of it. We have ways to do rehydration and stuff. It's very straightforward. Yeah, they're not at odds at all. They're totally different. Yeah.
So if I did use virtual DOM in case of replacing, I use virtual DOM to generate static content. What makes this very much faster or slightly faster?
Okay, the question was, is this faster than using the virtual DOM to generate static content? Correct? And also, is that a separate question? Okay, so the second question was, does this take a lot of configuration? So for the first one, I would say I've never heard of a time where virtual DOM was used to generate static content. I don't think that's the purpose of virtual DOM. It's not, yeah, I'm sorry if that's a bad answer, but nobody uses it for, it's not a tool for generating static HTML. Like I said before, virtual DOM is for doing HTML diffs in live JavaScript and updating data. It's for like data binding. And it's an amazing tool, but it's not in any way comparable to this tool at all. Is this complicated to configure? I would say no. I've tried to make it as easy as possible. You saw configuration in our live code example. There are a few examples of it. It's just you run a function and you pass plugins to it, and then the plugins do their transformations, and that's it. So this could be used in a static generator. Yeah, that would be the best place for it, because it also will generate a function. So if you want to use it for client-side templates, you can do that. I would not recommend doing that over using something that does implement virtual DOM, unless you have a very simple site and you don't want to deal with extra dependencies. Does that answer the question? Okay, cool. Anything else? I think I'm out of time here.
We have one more.
Yes, that was one of our first features we did. We actually have a general purpose content transform. So what you do is you just pass any markdown library into that and it will do it, or any other library it'll do it. But we do have one that's pre-configured for markdown. I actually build my own static site generator as an alternative to Jekyll. We tried out Jekyll and it didn't quite do the trick for us as far as the scope of projects and flexibility that we have. So we have a static site generator that I would honestly say is objectively superior to Jekyll at this point. It can directly replicate every one of Jekyll's features, but do a lot more than it. It's called Spike, if you want to check it out. And it uses Reshape out of the box.
All right, awesome. Let's give Jeff another round of applause.